Welcome to my channel. Today I'm back with a solution to one of the questions from INMO 2022. So let's get started. The question says, for a positive integer n, let t of n denote the number of arrangements of the integers 1, 2 and so on up till n into a sequence a1, a2 and so on up till an, such that ai is greater than a2i and ai is greater than a2i plus 1, where I is defined. For example, t3 is 2, since the possible arrangements are 3, 2, 1 and 3, 1, 2, and we have to find out t7. So the question basically says that for a given integer n, all the numbers from 1 to n are to be arranged in a particular sequence a1, a2, a3 and so on up till an, where these denote the positions by satisfying some conditions. The conditions being ai is greater than a2i and ai is greater than a2i plus 1 for all I 1 is less than or equal to I less than 2i less than or equal to n. 1 is less than or equal to I less than 2i plus 1 less than or equal to n. And we have to find out t of n, which is the number of arrangements that satisfy the given conditions. Let us understand this better with the help of an example where let n be equal to 3. So the numbers or the integers that we have are 1, 2 and 3. These are to be arranged in a certain order a1, a2 and a3. What are the possible arrangements with 1, 2 and 3? 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2 and 3, 2, 1. Now let us take a look at the conditions. The conditions are ai should be greater than a2i and ai should be greater than a2i plus 1. Let I be equal to 1. In that case, a1 would be greater than a2 and a1 would be greater than a3. So these arrangements should satisfy that a1 should be greater than a2 and a3. In these two arrangements, a1 is less than both a2 and a3, so they don't count. In the next arrangement, a1 is less than a3 and a1 is less than a2 in the other one, so these two don't count either. The only arrangements that satisfy these conditions are 3, 1, 2 and 3, 2, 1. So therefore, t of n, which is the number of arrangements that satisfy condition, t of 3 is equal to 2. Now let us use the same method to find out the number of arrangements that satisfy the condition for t of 7. That is, n is equal to 7 in this case. The integers that we have would be 1, 2, 3, 4, 5, 6 and 7 to be arranged as a1, a2, a3, a4, a5, a6 and a7. Right, so let us write the conditions as well that we would be using while finding out the solution. ai must be greater than a2i and ai must be greater than a2i plus 1. a1 is greater than a2 and a1 is greater than a3. a2 is greater than a4 and a2 is greater than a5. a3 is greater than a6 and a3 is greater than a7, when I is equal to 1, 2 and 3 respectively. Okay, so first of all, if you guys observe, a1 is greater than a2, which is greater than a4 and a5. As you guys must have already seen, a1 is greater than a2 and 3. a2 is greater than a4 and a5, and a3 is greater than a6 and a7, which means a1 is basically the greatest among them all. So a1 must be filled with the greatest number of the given integers, that is 7. Now to fill the other digits, let us go about it by cases. Case 1 being a2 is equal to 6 and a3 is equal to 5. Our case 2 will be A2 is equal to 5 and A3 is equal to 6. The thing that you to observe here is A2 must be greater than A4 and A5, whereas A3 must be greater than A6 and A7. So if A2 was filled with 6 and A3 was filled with 5, A4, A5, A6 and A7 must be filled with 1, 2, 3 and 4. There would be a problem or a condition that we have to resolve here, because both 6 and 5 are greater than 1, 2, 3 and 4, and filling them in any order would not bother us in any way. However, the number of ways, the number of arrangements, different arrangements that we get is very important. So let's calculate it. There are 4 positions with 4 numbers to be filled in each. That is 4p4, which is equal to 4 factorial, or 24. Similarly, if 5 and 6 were interchanged, it wouldn't cause much problem either, because both 5 and 6 are all greater than 1, 2, 3 and 4. So the number of ways again here would be 4p4, which is equal to 4 factorial, is equal to 24 ways. Moving on, the third case that we will be dealing with be, let A2 be equal to 6 and A3 be equal to 4. A2 be equal to 4 and A3 be equal to 6. Now that in case 3, we fill A2 with 6 and A3 with 4, right? The digits that we have left are 1, 2, 3, 5. So A4, A5, A6 and 7 must be filled with A1, 2, 3 and 5. There won't be any problem of whatever we fill in A4 and A5, since 6 is greater than all 4 numbers here. However, if you've noticed, A3 is filled with 4, which is less than 5, which is less than one of the numbers. So 5 cannot be filled in A6 and A7, because if it was filled, A3 would become less than A6 and A7. That would contradict the condition. So 5 does not go in A6 and A7. So 5 could go in 2 other places, that is A4 and A5. So if 5 was in A4, there would be 3 factorial ways of filling it. And if 5 was in 3 factorial ways of filling A5, A6 and A7 with 1, 2 and 3. However, if 5 went in A5, there'd be again 3 factorial ways to fill A4, A6 and A7 with 1, 2 and 3. So that would be 2 into 3 factorial ways. That is nothing but 12. There are 12 possible arrangements with 7, 6 and 4 as the first 3 digits. Now, the fourth case is quite similar, if you understand. However, instead of A6 and A7, we have to take care of A4 and A5 such that they do not get filled with 5. 5 doesn't go in A4 and A5, because if it did, they would become greater than A2, which would again contradict our condition. So we do not want such arrangements. So 5 goes either in A6 or A7. That would be 3 factorial ways plus 3 factorial ways if it goes in A7. That would be 2 into 3 factorial, which is equal to 12. Now we're done with 4 cases. Moving on to the 5th case, let A2 be equal to 6 and A3 be equal to 3. Let A2 be equal to 3 and A3 be equal to 6. In this case, let's write that down again. 1, 2, 3, 4, 5, right? So the digits that we have would be 1, 2, 4 and 5. Now, as you can see, in the position of A2, there is 6, which is greater than all of these 4 digits. So it wouldn't matter whatever number went in A4 and A5. So we do not have a problem with that. However, 3 is less than both 4 and 5. So it has to be noticed that 4 and 5 cannot go in both A6 and A7, which means the only position they have would be A4 and A5. So 4 and 5 should fit in A4 and A5. So there would be two ways, 2p2, 2 factorial, two ways of filling 4 and 5 in A4 and A5, right? Into two ways of filling the other two numbers in the other two boxes. That would be 4. Similarly, if A2 is filled with 3 and A3 was filled with 6, there would be the same problem of not being able to fill 4 and 5 in A4 and A5. So 4 and 5 should go into A6 and A7, right? So that would be 2 into 2 ways again. That is 4 ways, right? You could also try the other, you could try changing it like 6 and 2. For example, I'll show it to you. If A2 is 6 and A3 was 2, the remaining numbers that we have to fill in would be 1, 3, 4 and 5. But as you can see, there are 3 numbers that are greater than 2, that is greater than A3. So but we have 2 positions that are to be filled such that the numbers are less than 2, but we do not have 2 numbers, we have only 1 number that is less than 2. So this arrangement would not be possible. So A3 cannot be filled by 2. Similarly, it cannot also be filled by 1. And if you want to try alternative, that is 7, 5 and 4, 6 must go in any one of these. But it is not possible as A2 and A3 are both greater than the remaining 4, right? So 6 could not go here. So this case scenario is also not possible. So there are 6 possible cases for it to occur. So let's add them up to find out the total number of arrangements that are possible and also satisfy the conditions. That would be 24 plus 24 plus 12 plus 12 plus 4 plus 4, which is equal to, let's solve it, 2 into t of 7 would be 2 into 24 plus 12 plus 4. That is 2 into 24 plus 12 plus 4, which is nothing but 40, which is equal to 80. So t of 7 would be equal to 80, which means there are 80 ways or 80 possible arrangements such that all the numbers 1, 2, 3, 4, 5, 6, 7 can be arranged into a certain sequence where A1 is greater than A2 and A3, A2 is greater than A4 and A5, A3 is greater than A6 and A7. So moving on, there's the next part of the question that says, if k is the largest non-negative integer so that 2 power k divides t of 2 power n minus 1, show that k is equal to 2 power n minus 1. So anyway, this information can be used to verify the answer that we got, that t of 7 is equal to 80. Now let's write t of 7 in the form of t of 2 power n minus 1. 7 can be written as 2 power n minus 1 when n is equal to 3. Okay, keeping this aside, we also need to find out the value of k such that it is the largest non-negative integer and 2 power k divides t of 2 power n minus 1. So 2 power k must be a factor of t of 2 power n minus 1. The possible values of k here would be 1, 2, 3 and 4, since 2 of k must be a factor of 80, right? However, since we need to find the largest value, k would be equal to 4. We can verify this by putting n in this equation. K is equal to 2 cubed minus 3 minus 1. K is equal to 8 minus 4. K is equal to 4. Since both the answers are matching, the value that we got, that t of 7 is 80, is the right answer. Thank you. Thank you for watching. Please don't forget to like, share and subscribe.